Hey everybody, today we're going to be converting between different units. And the Do Now question asked, how tall are you in inches? And it also asked, how did you figure it out? Now the reason for this is because on the Regents, what used to be the Regents, they used to ask a lot of questions that had to convert between inches and feet, but they never explicitly said the conversion rate for inches and feet. So some people, a lot of people come from countries where the metric system is more popular and inches are just confusing. And so one thing that's really helpful is that 1 foot equals 12 inches. So take some time now and figure out how tall are you in inches. Okay, so I'll go over this for my height because I don't really have anybody else's height available, and obviously this answer will vary depending on how tall you are. So for me, I am 5 foot 10 inches. So what I want to do first is obviously this 10 inches is going to be part of it, but I also have to figure out how many inches are in these 5 feet. So the way I like to do this is I always like to start with the conversion ratio and put it in a fraction. So I'm going to put 1 foot over 12 inches. And if you're asking yourself, are these labels important? Are these units? Yes, they are crucially important. This is so important. So then we're going to set up a proportion. And what we know here is that since the feet are on top on the left, it means feet are going to be on top on the right. And since inches are on top on the left, they're going to be on top on the bottom as well. So the information we know we have 5 feet. We're trying to convert that 5 feet into inches, so we don't know how many inches there are. Let's call it x. And now, the way you solve this, super easy, just cross multiply. We have x times 1 is x, and then we have 12 times 5, which is 60. Sometimes there's an extra step where you actually have to solve for x, but in this case, 5 feet just equals 60 inches. So, for the 5 feet, I have 60 inches, plus those extra 10 inches, I am 70 inches tall. And that's basically the strategy we're going to use for all of these things, and it'll get a little more complex than just this 1 foot 12 inches thing. So if you look here, today we're going to be converting inches. Tomorrow we're going to use three-dimensional shapes to model situations. So we'll have like a water tower, and that's made up of a cylinder and a cone or something along those lines. And then Wednesday and Thursday we're basically going to be putting these together. So we're going to first model real-life scenarios using 3D solids. Then we're going to use densities and convert to find things out. So like, for example, if we have a water tower, we could figure out how many liters of water there are. And if we know how many pounds per liter, we could figure out how many pounds of water there are in the water tower. And just quick heads up in the future here, we're wrapping up Unit 8. So the week after this, we're going to have a review on Monday and Tuesday, and then Wednesday and Thursday, you're going to have time to finish a project. So one thing I always like to think of with this unit conversion is the ever-present Michael Scott, and how he really screwed up his rabies awareness 5K. So for those of you that know, a 5K is 5 kilometers. Which, by the way, that's another thing they don't actually give you on the Regents, is that 1 kilometer equals 1,000 meters. Anytime you see kilo, kilo means 1,000. So actually 5 kilometers equals 5,000 meters. Now, on the flyer that Michael originally made, it said 5,000 miles. I don't care who you are, 5,000 miles is one heck of a difficult race. 5,000 meters, not that bad though. And also, just a quick shout out to my college here. The race was of course won by Toby Flenderson, played by Paul Lieberstein, who went to my alma mater, Hamilton College, and I once played a game of pool with him. So these right here are all the conversion ratios that you're going to need. These are every bit of the ones that are important for you. Basically, you should take a picture of this. I also posted it on Google Classroom as a reference sheet. You go down to the help material section and it's called reference sheet, and it has everything you need to know, but these are going to be wildly important for the next week and a half or so. Okay, so in this problem, we have the volume of a sphere, and it's 4,370 cubic centimeters. We want to figure out how many liters does this hold. So what you would do is you would look back at that sheet from the last slide, which I can't really go back to, but I've written these things down. And you want to find something where it's like blank centimeters cubed equals blank liters. Now, I already wrote these things down, but you can just check back on the sheet. It's there. And it says that 1,000 centimeters cubed equals 1 liter. So that's the way we're going to start this thing. We're going to start with 1,000 centimeters cubed over 1 liter. And now we're going to put in the information we know. So we have some sort of centimeters cubed, some sort of liters. The information we have is that we have 4,370 centimeters cubed. And since it says how many liters, we're looking for the liters, that's our x. Now we just cross multiply. So with that, we get 1,000x equals 1 times 4,370 is 4,370. And now to solve for it, we obviously have to divide by 1,000. And you get that x equals 4.37 liters. And that's the volume of the sphere in liters. So now we want to figure out how many gallons does the sphere hold. We have liters, so we're looking for blank liters equals blank gallons on the reference sheet. So go back to the reference sheet, check it out. I already got mine. Mine is 1 gallon equals 3.785 liters. And that's just straight from the reference sheet. Both of these two, straight from the reference sheet. You obviously do not have to memorize these crazy conversions. That feels like a lot of work. So we're going to start the same way. We're going to start with 3.785 liters over 1 gallon. And now we're going to plug in the information we know. So on top we're going to have liters, on bottom we're going to have gallons. We're looking for gallons, so that's x. And the liters, we have 4.37 liters. So for this, we're going to cross multiply again. We get 3.785x equals 4.37. Solve for x, divide by 3.785, cancel. Divide by 3.785, and you get x equals, calculator, and we'll call it about 1.15 gallons, rounding it off to the nearest hundredth. So that's how you do it. You find the conversion ratio that you care about from the reference sheet, set it up like a fraction. Then make a proportion where the units are the same on the top and the units are the same on the bottom. Plug in the information you know, 4,370 for this and x for that, then cross multiply and solve. So now it's time for you guys to start your worksheet, and one thing to think about is what about the wording of the problem? Lets you know that you're going to have to convert units. Do you see like a change in any words or anything? And don't forget, you have Delta Math due Tuesday at the beginning of class, which is tomorrow. Good luck.